Okay, so for us to look at angles that are greater than 90, we're still going to look at angles that are less than 90, so between 0 and 90, to try and come up with some strategies for dealing with angles greater than 90. But we have to come up with some, write down some definitions first. So when we're looking at angles greater than 90, and now for between 0 and 90, we're going to change our definitions a little bit for sine theta, cos theta, and tan theta. And that will also change our definitions a little bit for the reciprocal trig functions, secant, cosecant, and cotan. So we're going to look at the angles on a Cartesian plane. Okay, I'm going to draw a circle here, try to draw the best circle I can. Okay, and we're going to look at an angle. The angle is going to come from the positive x-axis. Okay, so I'm going to put the angle going greater than 90 degrees. I'm going to put this out here. Okay, so this straight line to the end of the circle is called a terminal arm. It's also called a radial arm. Okay, because it's the radius of the circle. So we're going to define this as the angle, theta, measured from the positive x-axis going counterclockwise. We can go clockwise, but that would then be called a negative angle. Okay, so if we went this way, that would be negative so many degrees. So because we're going counterclockwise, that's positive. Okay, so that's the positive direction going this way, negative direction going the other way. Now, we're going to define a point at the end of that arm as xy. Okay, so that's the coordinates of that point. And in a circle, this is called the radius. Okay, so that line, the length of that line is the radius. And we have a relationship between the radius and any point on the edge of the circle that we learned in grade 10. It's the equation of the circle. R squared equals x squared plus y squared. Okay, or R equals square root of x squared plus y squared. Okay, so theta is the angle measured from the positive x-axis going counterclockwise. Okay. Sorry, counterclockwise. Okay. And this thing is called the terminal arm. And now we're going to define sine theta, cos theta, and tan theta as, so sine theta is y over r, cos theta is x over r, and tan theta is y over x. Okay. And I'm going to show you kind of why. So we're going to drop perpendicular from the tip of that arm there. Okay, so drop perpendicular down, so that's 90 degrees. And I'm going to then define an angle in here. It's going to be called alpha. Alpha is going to be called the related acute angle. Okay. So over on the side here, I'm going to write that out. Alpha equals the related acute angle. Okay? And it's measured from the terminal arm to the closest x-axis. Okay? So not necessarily the positive x-axis or negative, the closest x-axis. Okay? So measured from the closest x-axis to the terminal arm. Okay. I'm going to call it alpha. And in short, related acute angle, RAA, we can use to name that. Okay. The x and y coordinates will have signs now. So sine theta, cos theta, and tan theta are not just going to be positive anymore. Once you go outside that first quadrant, okay, so the positive x and y axis quadrant here, once you go outside that, you can have negative x and y values, right? So for example, this point here, the x coordinate is negative. Okay. So if I'm looking at cos of theta, it's going to be negative something over r. Okay. For tan theta, if we took tan theta in this angle here, we'd have both, or we'd have x equals negative and y would be a positive. So tan theta would also be negative. Sine theta in this quadrant here, though, because y is still positive, would be positive over positive, and so sine theta would be positive. The radial arm, the radius, is always going to be positive, no matter what quadrant you're in. So it's only going to be the x's and y's that are negative. Okay, so how did we get these formulas? How did mathematicians get these formulas? Well, what we worked with here is the related acute angle. Okay, so instead of working with the actual angle, we looked at the related acute angle, which is we defined as alpha here, and then we dropped this perpendicular down so that we can look at this triangle over here. Okay, so this is where we go back to SOHCAHTOA. Okay, so our formulas for trig ratios when we're looking at angles less than 90. So if we just look at this triangle here as its own entity, and this is the angle, well, the opposite side to alpha is the y coordinate. So it's the height, which is the y coordinate. The adjacent side is the x coordinate. Okay, so this is the x here, and this is the y. And then we still have the radial arm as r. So sine theta is opposite over hypotenuse. The hypotenuse equals r. Okay, so we should write that here. The hypotenuse equals r in all these triangles. So sine theta equals y over r. So if you're wondering how to get this, instead of memorizing these, you can go back to your definition for SOHCAHTOA. Cos theta, so alpha, if we're looking at alpha here, cos is x over r because it's adjacent over hypotenuse. Okay, and tan theta is y over x, okay, opposite over adjacent. So if we went down to this quadrant down here and had the terminal arm, we would have the angle, which would be greater than 180 degrees, but a point down here would have a negative x and a negative y. So in that case, if you had a negative x and a negative y, sine theta would be negative, cos theta would be negative, but tan theta would be positive because the two negatives would cancel out. Okay, so let's try an example here. Let's call this example 1. And let's just put a terminal arm up here. I'm not going to put in the circle now. I'm just going to put the coordinates of the point. So 3, 4. Okay, so that would be 3 on the x, 4 on the y. And if we want to find theta, well, theta happens to be less than 90, so we're used to this one. Okay. And if you wanted to find sine of theta, cos theta, tan theta, this one, well, we know what the x-coordinate is and the y-coordinate is, but we need to find out what r is. So r is the length of that. Okay? So how do you find the length of that line? Well, you just use Pythagorean theorem. Drop a perpendicular down there. This length here is 3. This is 4. So r equals the square root of 4 squared plus 3 squared. Okay? So if we go back up here, r is the square root of x squared plus y squared. That's what we got from the equation of the circle. So if you work that out, you get the square root of 16 plus 9, which equals root 25, which equals 5. Okay, so the radius of this line, or the length of that line, is 5. So then sine theta equal to y over r is going to be 4 over 5. Cos theta is going to equal x over r, which is 3 over 5. And then tan theta is going to equal y over x, which is 4 over 3. Okay, and if you had to find that angle, then you just pick one of them and do the inverse. Okay, so theta equals sine inverse of 4 over 5. If you plug that into your calculator, you're going to get approximately 53.1 degrees. Okay, I could have done cos inverse of 3 over 5. I would have got the same angle. Tan inverse of 4 over 3. I would have got the same angle. Okay, so I could just write over here equals cos inverse of 3 over 5, and it also equals tan inverse of 4 over 3. Okay. In this case, when the angle is in the first quadrant. So what I mean by first quadrant is this one where the angle is between 0 and 90. Okay, so this is how you normally had trig working. This isn't necessarily true once we go outside the first quadrant.